Our topic for today is the mole concept. What is the definition of the mole? A mole is the amount of substance which contains the same number of particles. That is, we are talking about atoms, molecules, or ions, any of them, as they are in 12 grams of carbon 12. Now, this is the definition of mole concept, and what is it trying to tell us? Now, pay attention. You see, there are some words that we use in our daily life. Words like if I say I need 1 dozens, if I say I need 1 dozen of, if I say I need 1 dozen of chair, beyond that word, I'm talking about 12 number of chairs. Everybody know this very well, so I'll be using this. So if we say 1 dozen, this is it. In other words, this dozen, we all know that word. It is a number that represents certain number of substances, same as the mole. Now, pay attention that scientists needed an an element that will be used as a standard for all other elements in the periodic table. That is for all other elements we have. And the element that they are picking as a standard here is carbon 12. Carbon 12 is a stable isotope of carbon. Is a stable form of carbon. That is carbon 12. Now, the definition says that what? A mole is that amount of substance which contain the same number of particles as they are in 12 grams of carbon 12. Now the question is, how many particles are in 12 grams of carbon 12? That is it. So take note that what 12 grams of carbon 12 has this number of particles, which is what 6.02 times 10 to the power of 23 particles. I'll say that again. That is, they said the amount of substance which contain the same number of particles as they are in 12 grams of carbon 12. Now the question is, how many particles are in 12 grams of carbon 12? They are 6.02 times 10 to the power of 23 particles. It means that if I'm saying I need 1 mole of sodium, it means that what? It is the amount of sodium that contains 6.02 times 10 to the power of 23 particles, and that is it. Now, it means that, simply put, 1 mole of any substance, 1 mole of any substance is equals to 6.02 times 10 raised to the power of 23 particles. That is, 1 mole of any substance contain this. If I say 1 dozen, you will give me 12. Similarly, if I say 1 mole, you will give me 6.02 times 10 raised to the power of 23 particles of that substance I'm talking about. And what is this particle called in chemistry? This particle is called, this number is called Avogadro's number. It is called Avogadro's number. Avogadro's number. Avogadro's number. Exactly. Avogadro's number. We always represent this number as Na. Avogadro's number. That is it. So if they ask you what is 1 mole in chemistry, 1 mole is equals to what? 6.02 times 10 to the power of 23. And that's that for that. So thanks for watching this section. Now let's look at the formulae for calculating mole. You see, for exam focus, their question on mole concepts can come in various patterns. So each of the pattern has the formula that you can use for them and how to even know you are going to use a particular formula. Now, before I discuss any formula here, take note of something we call molar mass. There's something we call molar mass in chemistry. What is that? Now, pay attention to something. There's something we call molar mass. So pay attention to that. Molar mass is what? How do we define molar mass? Molar mass is the mass of 1 mole of a substance. Again, can you define it out loud? Molar mass is the mass of 1 mole of a substance. You see, in a simple language, molar mass is, you are looking at how heavy is 1 mole of a substance. That is, give me 1 mole of a substance and I weigh the mass. What is the mass? What you've gotten is the molar mass. That is the mass that 1 mole of a substance will give me. Let me give you an example. If I say 1 mole, if I say 1 mole of magnesium, if I say 1 mole of magnesium is equals to 12 grams, what does that mean? It means that if you pick 1 mole of magnesium and you weigh it, it weighs 12 grams. So from this statement, 1 mole of magnesium equals 12 grams. If they should ask you that, what is the molar mass of magnesium? Molar mass of magnesium is what? Is 12 grams per mole. This is the unit of molar mass. The unit of molar mass is what? Grams per mole. That is, the gram of 1 mole of that substance. That is what it means. Altogether, okay, another one. If I say 1 mole of oxygen is equals to 16. Look at this. So 1 mole of oxygen is equals to 16 grams. What does that mean? It means that what the molar mass, that is the gram of 1 mole, is equals to what? 16. Okay, who can interpret this for me? You do that in your note and you compare it to what I'm saying. Okay, if I say 1 mole of if I say 1 mole of neon is equal to, okay, let me use this one I've been using. Let me use 1 mole of sodium is equals to 23 grams. Now, who can tell me what is the molar mass of sodium? It means that molar mass of sodium is equals to what? 23 gram per mole. That is 1 mole of sodium weighs 23 gram. So that's the concept of what? Of molar mass. So it means that in a layman language, we can say, oh, molar mass. You think that we can say that molar mass is equals to what? Mass per mole. That's what we have been saying, right? Mass per mole. Good. Molar mass is equals to mass per mole. Therefore, if I try to cross multiply and just change position of this and this, that is swap their position, it means that mole is equals to mass over molar mass. That's where the formula is coming from, one of these famous formula in mole concept. So this is the first formula we'll be treating here. Mole is equals to mass over molar mass, and the unit of mole is mole, like this. So that is that for that. The unit of mass is grams, and the unit of molar mass is what? Gram per mole. Please take note of all this, and we move in our next lesson. Now let's look at the formula for calculating mole. So the first one we discussed in our previous video was mole equal mass over molar mass. Take note of that. When are you to use it? You have to use this whenever they are mentioning mass or they want to find the mass. Whenever the mass is given or they wanted to find the mass, please take note you are using mole equal mass over molar mass. Secondly, we have mole equal number of particles over Avogadro's number. This is Avogadro's number. Now, what is this formula telling us? Please pay attention. You see, whenever you want to know that particles are being given in that question, take a look. Particle can be atoms, molecules, ions. Are there? If they mention any of these, for example, they say calculate the number of mole in 2.01 times 10 raised to power 4 atoms of magnesium. For you to hear this word atoms, it means that they are giving you number of particles. Then you are using this formula. You see, whenever any of this is mentioned, atom, molecule, ion, please reflect back to this formula. Good. Next, this one has to do with gases. Altogether, this is how to calculate mole of gases whenever the volume is given. The mole is equal to a volume given at STP. STP is a standard condition in chemistry. It means standard temperature and pressure. Altogether, good. Standard temperature and pressure, that is what it means. So mole is equal to a volume given at that condition over any of these number. It depends. If they give you this volume in dm cubed, decimeter cubed, then you use this one, 222.4. That's it. The unit have to correspond. It will be wrong that they'll give you your volume in dm cubed, you will not be using this in cm cubed. That will be very wrong. Why? The units are not corresponding. Now, if they give you this volume at STP in centimeter cubed, then you say mole equal volume at STP over 22400 cm cubed. Aha. So if this is in cm cubed, you make use of this formula. Good. Lastly, mole equals CV, or you say CV over 1000. Well, they are the same. If they give you the volume in dm cubed, decimeter cubed, you will use mole equals CV. If they give you the volume in centimeter cubed, therefore, you say mole is equals to CV divided by 1000. You see, let me tell you one idea. You see, the idea is that dividing this volume by 1000 is taking this back to dm cubed. Don't forget, that is centimeter cubed divided by 1000 will take you back to decimeter cubed. So they are the same thing. If they give you in dm cubed, you use this. If they give you a volume in cm cubed, you use this. What is C? C is concentration, or they call it molarity. C is concentration or molarity, and that's equals to, the unit is mole per dm cubed. If you see this, or you see something like this, mole per dm cubed, they are giving you concentration. Or this one is called molar, capital letter M. Any of this can be the units. Whenever you see any of this, those are the units for concentration. And lastly, V is the volume. So these are the formulae for calculating mole concept. Jot them and digest them very well. That's it. Now let's look at this question. We have example 1, that is on mole concept. So they said, what example? They said calculate the molar mass of the following. So solution. So we want to calculate the molar mass. Now the question is, how do we calculate the molar mass? Now I have a good news for you. We calculate molar mass exactly we calculate the relative molecular mass. That is just it. But after calculating molar mass, you must include the unit gram per mole. That is just the difference. Okay, let's go. Look at what we have. We have Mg3 PO4 2. So first, if you look at this, if you observe, you see that I have 3 magnesium there. I have 2 phosphorus. Do you see that? 2p. I have 2 phosphorus. Also, I have 2 times 4, 8 oxygen. So I have them here. So the question, actually, you'll be given that magnesium is equals to what? You have magnesium to be equal to, that is 24. You have P to be equal to 31. You have O to be equal to 16. You'll be given in the question. Okay, so this is what you have. So let us substitute. So you have 3 times magnesium is what? 24 plus 2 times 31 plus 8 times what? 16. That is it. Okay, so this will give me what? So what do I have? 3 times 24, that will give me 72, plus this is what? 62, plus I have 8 times 16, that will give me what? 128. So if I calculate this together, 128 plus 62 plus 72, what would that give me? That will give me 262. So my answer is 262 gram per mole. That is the molar mass. We calculate just the same way we calculate the relative molecular mass, as I've said earlier. So let's go. Question B. We have C3H6O3. So here you'll be given that carbon equals to 12, H equals 1, O equals 16. All together? So let's go. So if you observe this formula, you see that I have 3 carbon, 6 hydrogen, and I have 3 oxygen, as you can see here. So we substitute 3 times. Carbon is 12, hydrogen is 1, oxygen is 16. So what would this one give me? I have 36 plus 6 plus 3 times 6 is 18, 8 keep, and that's 48. So if I add all this together, what will be my answer? Permit me to write it here. So I have 36 plus 6 plus 48. That will give me 90. So I have 90 gram per mole. So let's go on. You can pause the video to try the third one by yourself. There's no harm in trying. Okay? Good. So after trying, let's attempt this together. I have KH2PO4. If you observe this, I have just 1 potassium, I have 2 hydrogen, I have 1 phosphorus, and I have 4 oxygen. Do you see that? Good. To break it down this way is the most suitable way for you to do it. It's beginner friendly. So potassium that I see here is 39, hydrogen is 1, potassium and phosphorus is 31, and oxygen is 16. So let's go. This will give me 39, 2 times 1, 31 plus 4 times 16. So this will give me 39, 2, 31 plus 4 times 16 will give me 64. Then we go on to add together. So I have 39 plus, YX students we have calculator, JAMB students also have calculator at the top of their screen. So there's nothing to worry about, plus 64. So I have 39 plus 2 plus 9 plus 64. I have 136 gram per mole. That is that for that. Thanks for watching. Okay, we have this question. How many grams are in 1 mole of iron trioxide, Fe2O3? Okay, so if you can remember very well, we said the concept of molar mass is that molar mass is the what? Is the mass of 1 mole of a substance. We've learned this already. Now, they say how many grams are in 1 mole of Fe2O3? You see, grams in 1 mole. They are saying mass in 1 mole, and that is actually molar mass. In other words, you are asked to calculate molar mass of what? Fe2O3, and that is it. So let's get the molar mass of Fe2O3. And from this formula, you can say I have 2 atoms of iron. Also, I have 3 atoms of oxygen. And surely you'll be given that Fe is 56, O is 16. So I have 2 times 56 plus 3 times 16. Are you there? Good. So 2 times 6 is 12, 2 keep 1. 2 times 5, 10 plus 1, 11. 1 on 2 plus, this is what, 48. All together. So let's go. So I have 1, 1, 2, 48. What would that give me? This is 10, 0 keep 1, 4, 5, 6, that's 160. So my answer is what? 160. Don't leave the answer this way. Since you are calculating molar mass, put it as gram per mole. Guys, that's that for that. Or you can see some people write it this way: 160 gram per mole. No problem, they are the same. That's it. Now we have this question on mole concept. So let's start from this first question. They said, how many moles of nitrogen are there in 2.8 grams of nitrogen gas? How do we solve this question? Well, solution. Don't forget, kindly jot down the formula given you on how to calculate mole concept. Now, if you observe this question, you were given something here. You were given 2.8 grams. Now, these grams will let you know that this 2.8 is the mass you were given. So we have the mass, which is equal to 2.8 grams. And take note that we can get the molar mass, but what we have here is nitrogen gas. Nitrogen gas, I want to ask a question. Is it N or N2? The atomicity of nitrogen is 2. It's a diatomic gas. Therefore, nitrogen is written as what? N2. Are we together? N2. Good. This is nitrogen, N2. So therefore, we can get the molar mass. So what is the molar mass? The molar mass of nitrogen gas will be, this is 2 multiplied by N is 14. And that will give me what? That will give me 28 grams per mole. That is the molar mass. So this is the mass, this is the molar mass. So which formula for mole relate mass and molar mass together? Everybody know that what? Number of mole equals to what? Mass over molar mass. And as we have it here now, the mass we have here is what? 2.8 divided by, you see, the molar mass we have here is what? Is 28. So how do I divide this? Well, I can multiply up and down by 10. If I don't want to make use of calculator, I can multiply up and down by 10. If I do that, I'll be having times 10 times 10. So what will this give me? This will give me, my mole will be equal to, this 2.8 times 10 will give me 28, because this 10 will shift the decimal point outside. So over, this will give me 280. So 28 here 1, 28 here will give me what? 10. So I have 1 over 10. 1 over 10 is now what? 0.1. So I have 0.1 what? 0.1 mole. So that's my answer to the question. Now the next question I'm having here is this. They said, how many moles? They said how many moles of glucose are there in 1.09 gram of this substance? The same way, this 1.09 grams represents the mass. So the mass is equal to 1.09 grams. And looking at glucose, this is 66H12O6. 66H12O6. So let us get the molar mass. The molar mass. See, as you're looking at it, you know that I have 6 carbon. That's 6 times the atomic mass of carbon is what? 12. So I have 6 times 12. Plus, I have 12 times hydrogen here, that's 1. 12 times 1. Plus, I have 6 times oxygen here is what? 16. And that's what I have. So if you do that and you add everything together, you're going to get 180 gram per mole. Okay, that is, multiply this, add it with this, add it with multiplication of this, you get 180. Then remember that number of mole is equals to mass over molar mass. So what's the mass? The mass I have here is 1.09 divided by 180. So if I do that with my calculator, 1.09 divided by 180, so this will give me what? 0.00606. Okay, so this is my answer, mole. Or in standard form, I could get that as 6.06 times 10 to the power of negative 3. That is shifting this way 1, 2, 3 times. And if you are going outside, this will be negative. And I shifted 3 times, that is 3 mole. So this is the answer to the question. That is that for that. Thanks for watching. Now let's look at work example 4. A sample of aluminium has a mass of 6.3 gram. So the mass of aluminium that we have here is what? 6.3 gram. They said how many molecules are there in this sample? Okay, so we are asked to find the number of molecules that are there. remember when we're discussing mole concept, I told us that this NO that you see here represent number of particles. And in chemistry, whenever you hear the word particle, know that it can either be atom, molecule, or ion. So here you're asked to find the number of molecules, so know that you're also asked to find the number of particles. They are the same words. Okay, good. Now, how do we now solve this question? Pay attention. The mass of aluminium given in this question is 6.3 grams, and we are asked to find the number of molecules. This is it. Well, pay attention to something. Did you know that I can say, whenever we are having mass in gram, mole is equal to mass over molar mass. Are we together? Mass over molar mass. Also, whenever we are having number of particles in chemistry, we can also say this mole is also equal to what? Number of particles over Avogadro's number. Are we together? You can see this formula are for mole. So because we are giving mass in gram, I wrote this formula, mole equal mass over molar mass. And because we are giving number of particles or molecules, so we got this formula, mole equal NO over Avogadro's number. We'll blend them together. Therefore, you see this formula is actually the one I'll be using to solve. Now pay attention. The molar mass of aluminium is 27. Aluminium is just a monoatomic element. Just one. It's a metal, just 27. Now let's go. What is the mass of aluminium in the question? That's 6.3 over, what is the molar mass of aluminium in the question? That's 27, equal to, what is the number of molecules? We are asked to find it, divided by Avogadro's number is 6.02 times 10 to the power of 23. So let's go. From here, when we cross multiply, we'll be having 27 times NO. That is this multiply this and this multiply this, equals to 6.3 times 6.02 times 10 to the power of 23. Now, because we are looking for NO, we'll divide both sides by 27, right? So divide both sides by 27, divide both sides by 27. So this and this will take care of each other. Then after that, what do we have? We have number of particles equal. Then you see, this is what I will just do. If it is for JAMB students, they don't have a calculator to carry out this, so I will just say do 6.3 times 6.02 divided by 27. Just do this first. So I'll be using my calculator from here. So I'll be doing 6.3 times 6.02, 6.3 times 6.02, then divided by 27. So this, everything here give me 1.405. That's what I have. After doing this and this, I have 1.405. Then I'll just bring my 10 to the power of 23 molecules. Guys, that's how to solve the question. As simple as that. So let me just re-explain again so you get the concept. Because we're given mass, we wrote this formula. Because we're asked to find number of molecules, also we wrote this formula. So the thing is that the idea is that we know this, we know this number, but we don't know this. You can just solve the equation from there, and that's that for that. So thanks for watching. Now let's look at this question. They said, how many molecules are there in 25.5 grams of ammonia? Okay, 25.5 grams of ammonia, that is the mass. Sorry, that is the mass. We have the mass. That is 25.5 grams. And if you look at ammonia, the formula for ammonia, don't forget, ammonia is NH3. Don't forget this from now on. You've learned a new thing today. This is ammonia, NH3. So we can get the molar mass of ammonia. So the molar mass of ammonia, NH3, is equal to, check. N is just 1 here, and that is what? 14. Sorry, this is 14, not 17. This is 14. Okay, that's 14. So I have 14 plus 3 times what? Hydrogen is 1. 3 times 1. And you know that 3 times 1 is 3. 3 plus 14 will give me 17 grams per mole. That is the molar mass of ammonia. Now, we have the mass, we have the molar mass. But the question asks us to do something. They ask us to calculate the number of molecules, and that is what? N0. We have to calculate this. And remember, we have mass and molar mass. That makes us remember that mole is equals to mass over molar mass. Right? Good. Also, there is number of particles there. So you say mole equal number of particles over Avogadro's constant. 6.02 times 10 to the power 23. Are you there? Now, we have this, we have this, we have to calculate this. So therefore, what is the mass? 25.5 divided by the molar mass is 17. We don't know n naught divided by 6.02 times 10 to the power of what? 23. All together. So from here we cross multiply. Now when we cross multiply, what do we have? This multiply, they have 17 times NO equal 25.5 times 6.02 times 10 to the power of 23. Now from here, I'm looking for n naught. I'll divide both side by 17. This will cancel this. Therefore, I'll be saying NO equal the whole of this. So just keep this 10 raised to the power 23. Keep it somewhere. Then what is left for you to do is just to punch other things that you have. Now press 25.5 times 6.02 divided by 17. That will give me 9.03 times 10 to the power of 20. So this is my answer. The input was molecules. I believe that is clear. That's just the concept. So the next question is this. They said calculate the mass. Calculate the mass. It means that we don't know mass in this question now. You can pause this video to try this question out. Let's see if you get the understanding. Now, the next thing I will calculate the mass of 3.01 times 10 to the power 22 molecules of water. So we have the number of molecules of water. That's 3.01 times 10 to the power of 22 molecules. So we have these molecules. Now, what do we do? Well, I have mass. Let me try to get my molar mass so that everywhere will be clear. Molar mass of what we are dealing with here is what? Is water, H2O. That's 2 times 1 plus oxygen is 16. And that will give me 18 grams per mole. That's for water. Now, I'm having mass. I'll say mass over molar mass. That's for number of mole. Don't forget. Because I'm having mass, I'll say number of mole equal mass over molar mass. Also, because I'm having this, I'll have NO over Avogadro's number. Try to revise the formula on more concepts. So what do we have here? Well, our mass, let me go to the next page. Our mass is what? We don't know the mass, M. But the molar mass is what? 18 equal the number of molecules we're given 3.01 times 10 to the power of 22. Let me cross check that. I think that's it. Okay, good. Divided by Avogadro's number, which is 6.02 times 10 to the power of what? 23. Now pay attention. This here 1, this here will give me 2. This here 1, this here will give me 10 to the power of 1. So I'll be left with M over 18 equal to 1 over 10 to the power of 1 is 10. 10 times 2 is 20. So cross multiply. I have 20m equal 18 times 1 is 18. Then divide both sides by 20 because you are looking for m. So I have m equal, what's 18 divided by 20? Divided by 20. That will give me 0.9 grams. So that's my answer. Let's look at this next problem. If 200 centimeter cubed of a gas at STP has a mass of 0.268 grams, what is the molar mass of the gas? Now, we have the volume of the gas given at STP. So you have the volume at STP. What's the name of STP? Standard temperature and pressure, and that's 200 centimeter cubed. Now, we have the mass of the gas, and that is equal to 0.268 grams. Now we have to get the molar mass. So what is the molar mass of the gas? Okay, we all know something, that whenever we are given the volume at STP, we all know that what the formula can either be volume at STP over 22.4 dm cubed, just as we have the dm cubed here, or the formula is volume, or we use 22400 cm cubed. Now who can detect? Is it this first one we are using in this formula or this? Now, look at the volume you were given. The volume you were given here is 200 centimeter cubed. Now, because you have centimeter cubed here, you have to use this so that the units can correspond. Therefore, the formula you are going to be making use of in this question, will be 22400 cm cubed. Yeah, good. So I'm using this formula because I'm having volume. Also, because I'm having mass, number of mole is also equal to what? Mass over molar mass. You see, what you are given in the question will let you know the type of formula you'll be using. Now, we are equating these two formulas. So what's the volume at STP given? 200. divided by, we have 22400 equal to, the mass we have here is what, 0.268 grams divided by, what's the molar mass of the gas? That we asked to look for. So let me just say the molar mass is this, mm. So we are looking for this. So what will you do here? You cross multiply. If I cross multiply, what will I have? What you have here, multiply this. We have 200 mm equal to this, and this will multiply. So I have 0.268 times 22400. Now I'm looking for molar mass. I'll divide both sides by 200. So let's go. This cancels this. So you know that these two zeros will cancel these two zeros. So 2 here 1, 2 here will give me 1, 2 here will give me 1, 2 here will give me 2. So it means that 2 in 224 will give me 112. Therefore, the molar mass is now what? 0.268 times 112. So what will be the molar mass? So I can use my calculator to just go about this. So what do we have? Let me get my calculator. So we have 0.268 times 112. So that will give me what? 30, approximately you have 30 grams. So we have about 30 grams per mole. So that is that for that. So that is the molar mass of the gas. So 30 grams per mole. So thanks for watching this section. Now we have this question. Work example 5. What mass of sodium carbonate is 500 centimeter cubed of 0.1 molar sodium carbonate solution? So this is what you have. Now pay attention that whenever you are dealing with questions that have to do with concentration and volume, the good news is that you can actually use mole concept to solve such question. Don't forget that whenever you are given concentration in this question, 0.1 molar you have here stands for concentration, and 500 centimeter cubed that you have here is the volume. Okay, so when we have this question, how do we solve it? Always recall this, that number of mole is equals to CV over 1000. Why am I using over 1000? It is simply because the volume of what you have here of this sodium carbonate is in what? Is in centimeter cubed. If it's in centimeter cubed, you put over 1000. If it's in dm cubed, decimeter cubed, you just get mole equals CV. Good. Now, because the question actually mentioned mass also, because mass is being mentioned in this question, remember the formula for mole that have to do with mass is mole equal mass over molar mass, right? So I'm now going to replace this mole with, mass over molar mass equals CV over 1000. I'm using this formula because we are asked to calculate mass, and the formula for number of mole that has mass inside, this is it. So this is the formula we are using to solve this question. Now before we proceed, sodium carbonate is this. As we've learned under compound, sodium carbonate is this, Na2CO3, like combination between sodium and the carbonate ion. When you exchange their valency and you have been taught, you get this. So let us get the molar mass of, that is the molar mass of Na2CO3. Now you have 2 atoms of sodium here, so you have 2 times the atomic mass of sodium is 23, so you have 23 plus, you have just 1 carbon here, the atomic mass is 12, plus you have 3, the atomic mass of oxygen is 16. So what do we have here? This will give me 46 plus 12 plus 48. So what would that give me? That 106. So let me confirm that. So using my calculator, there are 46 plus 12 plus 48. So I have 106 here. 106 gram per mole. That's the molar mass. Therefore, let us now proceed with the formula. So what is the mass? We are asked to find it. I'll say M over, what is the molar mass? 106 equal to, now C is concentration, and that is 0.1 times your volume is 500 centimeter cubed, then divided by 1000. Before you know that 500 here 1, 500 here will give me 2. Everyone knows that. So I have M over 106 equal to 0.1 over 2. So cross multiply. I will have 2M equal 0.1 times what? 106. So because I'm looking for m, I'll divide both sides by 2. Divide both sides by 2. So cancel, cancel. So I have m equal to, what will I have? So I have divided by 2. So that will give me 5.3. Therefore, our answer to this question is 5.3 grams. That's the answer. And the answer is what? Option B. So you can see that's how to solve the question. So thanks for watching.